Okay, I'm back. This is video number 2, and I don't know why I'm feeling like I want to use orange. It's bright. I'm not an orange fan, so it's usually, but I feel like it'll be good for this one. All right, 32. They're asking us to take an initial expression, and they're asking us to expand it using our formulas or identities, and basically tell us what the exact value is. Then they want us to graph the first one in your y equals screen, and graph the second one, and make sure that you are producing the exact same graph. I'm not going to do the graphing part, okay? But you can do that on your calculator. Just make sure that you put your calc in radians, okay, when you're graphing these. If you don't, then it's not going to give you what you're looking for. Remember, we're looking for the sinusoidal functions that look like, you know, this, all right? Okay, let's see, cosine, 5 pi over 4, okay, plus x. All right, so it's cosine of alpha plus beta situation. So we're going to use that identity, and we're going to expand it. So it's going to be cosine, my first angle, 5 pi over 4, 5 pi over 4, and then it's going to be the sine of, cosine of x. Sometimes I get them confused, y'all. Cosine of x, Miss Smith, cosine of x. All right, hope you can read that. Now I've just made a mess. Cosine x, all right. After that, we have minus, because it's a sign change in the cosine. All right, and that's going to be sine 5 pi over 4 times sine of x. All right, so there's no minus in the middle. Okay, so that's just the expansion. All right, so the cosine of 5 pi over 4, 5 pi over 4 is a pi over 4 family member. The cosine is radical 2 over 2, but you have to remember that 5 pi over 4 is going to be all the way in this quadrant. So it's going to be in quadrant 3, and according to a smart trick class, the only thing positive is tangent. So this will be a negative value. So it's going to be negative radical 2 over 2 times the cosine of x, all right, minus the sine of 5 pi over 4 is also going to be 5 pi over 4 is going to be quadrant 3. The only thing positive is tangent. So sine will be negative. And you know, the pi over 4 family members have the exact same x's and y's. Okay, and that's going to be times sine over x. Okay, so all we're going to do here is factor out the common factor. The common factor here is pause for 1 sec. Sorry guys, I got a little distracted on something. Okay, let's go back. Negative radical 2 over 2 times cosine of x. Negative times a negative here, you're going to multiply that. That becomes plus radical 2 over 2 times sine of x. Now we're going to pull out our greatest common factor. And our greatest common factor, we're going to leave the negative. So let's pull out a radical 2 over 2. All right? And that's going to leave us, if we, it's going to change the sign, right? It's going to change the sign. So if we leave the negative and we factor out a radical 2 over 2, then it's going to leave us with, so it will leave us with negative cosine x plus sine x. And let's switch that around. So it should be radical 2 over 2 times sine of x minus cosine of x. Okay, so we factored out this radical 2 over 2, but we left the negative in with the cosine, so it didn't change the sign here, but then we just flip-flopped them around because it looks better to have the positive ratio in front. So it's radical 2 over 2, parentheses, sine of x minus cosine of x. Okay, we're at number 49, and I know I jumped the gun a little. I just went ahead and wrote it down, and we're supposed to be able to confirm that we can convert this left side to look like the right side. So it's just like an identity verification. All right, so I took this statement and we are applying the sum of cosine, which is cosine alpha times cosine of beta minus sine of alpha sine of beta. And then I just put cosine alpha and cosine beta underneath because that's what the problem said to do. That's what they gave us. Okay, here's where you're going to use what we call decompose a function. Decompose a fraction, actually. All right, all this is this is the result of two fractions having been joined together. So we're going to write them as what they had looked like before we subtracted them. Well, if we subtracted them and they're sharing a denominator, that means they had the same denominator. We're going to split it. So we're going to call this a one fraction, cosine A, cosine B, over cosine A, cosine B. Yeah, we're going to get back to that. Hold on. And then subtract, all right, sine of A times sine of B over cosine A, cosine B. All right, now I'm going to kind of put those in parentheses so you can see them. Well, clearly this is going to all cancel out, right? Cosine A, cosine B, that's going to cancel out to 1. Minus, all right, if you split these two, they're being multiplied, then you can simply say this is the equivalent of sine of A over cosine of A times sine of B over cosine of B. If you're not sure that you have decomposed a fraction either by subtraction or multiplication, just multiply it back in your head and see if you get the original. Alright, so what we are now left with is 1 minus, this is the tangent of A, sine over cosine is tangent, right, times the tangent of B. Sine of B over cosine of B is the tangent of B. So we have verified both sides. Alright, so decomposition of fractions is huge in verification of these trig identities. You got to know when to split them apart and when the denominator stays the same, or when it, you know, you can break apart a multiplication one like this, and this denominator then became an individual cosine of A and cosine of B. But that's just decomposition of fractions. Okay, so that was number 49, and I'm going to address the next one, and hopefully I can fit it into this video. Stand by. Okay guys, I'm going to try to do 55 pretty quickly so I can finish this out in one video. This is one I told you was a bit challenging, but it's not that challenging, just setting it up is. Okay, so we have 3 triangles, right? And since we're talking about sine and cosine and stuff, I'm just going to make it a right angle. And of course they're giving us like alpha, and they're giving us beta, and they're giving us this is, not chi, I can't remember what it is in Greek. Anyway, I don't like it, so I'm just going to say A, B, and C, okay? So C is going to be this, A is going to be this angle, and B is going to be this angle. Okay, so they're telling us to prove this. The sine of alpha plus beta, and they're going to do, would they want us to do it in terms of, hold on, I got to pause. My notes are messed up. Hold on one second. Okay, I'm back. Sorry, I had to look at my notes for a second. Okay, they're asking us to prove or disprove that the sine of alpha plus beta is equal to the sine of C. Okay, well, one thing we know for sure, right, that alpha plus beta is equal to 90 degrees, and then there's our 90 degree here. So we know that 180 degrees minus A plus B, right? We don't know what the measures are, we don't have to know. But we know there's 180 total in here. And so now I changed this little funky symbol to C. So what we're going to say is the sine of the sum of alpha plus beta is the same as the sine. Now we're going to start with degrees because I want you to see it, right? The same as the sine of 180 degrees minus A plus B. Right? Because A plus B, let's say that A, and we know that A plus B is 90 degrees. Okay, so what we're saying then is the sum of A plus B, 180 minus A plus B, is going to leave us with C. Okay, and remember, I switched this symbol. So here's what we're looking at. This they're given to us. So now we're going to take this and see if we can work it out into something. So the sine of the two angles A plus B, let me rewrite this one more time. And since they're talking radians and we're talking radians, we're going to switch this and we're going to say 180 is equivalent to pi minus, right? And then pi minus C. Okay, hold on one second. Okay, I'm right on it here. Okay, so A plus B is 90, we know that, all right? And we know that this is 90. So we can just replace a plus b with c, because remember the answer is they want us to do it in terms of this little symbol, which we switched to c. All right. So here's what we're going to do. We're just going to take our expression, all right, and we're going to expand it based on the sine function. All right. So that's going to give us here the sine of pi times the cosine of big C, all right, minus the cosine of pi times the sine of big C. Okay, so the sine of pi, so that's the y coordinate at pi. Well, that value at pi, let me make sure I got this thing. All right, so that's going to be 0, right? Because 0 is the sine value of pi on the unit circle, times cosine of c minus, well, cosine of pi on the unit circle is -1, and that's times sine of c. Now remember, sine of c is a result of our having expanded this, and pi minus c is the same value as the sine of a plus b, because a plus b is 90 degrees total and c is 90 degrees. Okay, so we just rewrote this in terms of this, because that's what they asked us, and c had to be in there somewhere. Well, now that's going to be 0, right, minus negative sine of c, which is plus a positive. So if we want to revert back to that weird symbol, they said to do it, right? And we had to prove that this, and we did it. Okay, so you had to think in terms of the three angles, 180 degrees, that a plus b is going to be 90, because it's a right triangle, and c is 90. So we could just replace this with pi and this with c, because c is the same amount in degrees or radians as these two together. So we just used this, and we did the difference formula for sine, and we were able to bring it down to sine of that weird Greek letter. I can't remember what it is actually. But anyway, okay, hope that helps. Those are your videos, and happy Easter, and have a good break. We'll reconvene next week. Bye.